All right, great. Hi, I'm Tim, and in association with Michael and James from Victoria University. And today, I am going to be talking about the same thing that you just heard about. But I'm looking more at it from a practical point of view. And in particular, from a language design point of view, we're looking at if we want to combine nominal and structural types together, what sort of language design concepts do we need, and what sort of language design ideas can we learn from doing that? So the context of this talk is the Grace programming language. I'm not going to go too in depth into introducing it because I'm tired of introducing it over and over again. So the two important things you need to know are that it's structurally typed and that the class syntax you see is actually just sugar for objects that create other objects. There are no actual there's no actual class construct at the semantic level. So if there's anything else you're confused about in the language, just let me know and I'll explain what's going on. And what we're talking about here are brand objects. They're these first-class nominal types that we've implemented in the language, and they have both dynamic behavior, so they have the instance checking that we have store tags, and also there's static reasoning about them to essentially get back to nominal types. And because they're just objects, we can manage the sort of things we'd want to do with nominal types using existing object-oriented features. So this is a quote that I vaguely remembered when I was putting these slides together, and I was convinced that Andrew Black had said this, because this sort of summed up at least his opinion that I thought that he had on structural typing. So structural types correspond to the conceptual model of object-oriented programming, where individual objects communicate only via their interfaces. So it's sort of essentially the static version of duck typing. That was what we're really sort of describing here. And I spent 10 minutes trying to find where in the emails Andrew had said this, and then remembered that it was actually me that had said it. So this is in the paper. Yeah. So essentially just a quick recap so we know what's going on. Only the interface matters in structural typing. Person is someone who has a name, that's a string, and I have a name, that is a string, so I'm a person. And I don't have to say that I'm a person. My personhood is implicit in that I have a name. And so is anyone else who has a name as well. We're all people. And then this is an email I got after the paper was accepted that is actually a pretty good motivating example. And that's that sometimes structural types don't always encode the static constraints we want on objects. And so this quote was that sometimes there are things hidden inside of actual classes and we want to know that it actually came from a certain place because there's a hidden thing in there and we can't talk about hidden things when we're talking about structural types. And I think the specific example was there's a window and it has a frame inside of it, and that frame is some sort of actually special internal thing, and we need to have access to that frame in order to be able to draw the window on the screen or something like that. And the person who said this it's not that interesting that, he's not specifically a nominal types person. But this is interesting because it raises another question that I should probably address now, which is why do this in Grace and why not do it in Racket? So typed Racket has a structural type system on top of a existing dynamically typed language. And they want to do nominal typing. Is that all right? I haven't said anything wrong yet? Okay, good. So the reason they haven't done nominal type, I've had a lot of them coming up to me saying, we wanted nominal types because we want to do these sorts of things. And the problem they've had is that, first of all, they have first-class classes, which is now probably apparently a problem that's been solved. And they have dependent types, Andrew Kent's presentation, so they can probably do that now. So they should go off and sort this out as well. But the other important property is that they have type erasure, so the types disappear and they're not available at runtime, and that's probably not that important for them, but it is important for this talk, so keep that around. And then also there's, in terms of the language design issues, our dialects, which are systems for building DSLs, changing definitions that are in scope, and also writing static type checkers on a modular basis, they're sort of basically hashlang light, so they're not Racket languages, they're intentionally smaller in scope, and part of what we wanted to do here is work out, are they too small to actually build new type systems? Can we just do simple, like you can't use a class anymore, or all vars have to have a value after them when they're declared? We want to see if dialects are still powerful enough to do the things that we're talking about here. And then there's some other things as well, some other reasons we want nominal types. For instance, if you have everything as an object, and then a number is just something that is an object that has the plus and times and so on operators on it, then how do you add two numbers together? And this is interesting mostly because Andrew's admitted that they actually had to hack brands into Emerald in order to solve this problem in the 80s. Although he'll probably get at me for saying this because he now is of the opinion that that was just a performance thing and there should be more clever ways to solve this problem. But we're looking to recreate the brands, so I'm sure we can argue about that later. So here's sort of an idea of what brands, as they already exist, are. This is sort of a weird mishmash of Grace and the Unity language, which was Mallory and Jonathan Aldrich in 2008, I think. That was about taking nominal types and structural types and smashing them together. So we declare a class called window. It has some things in it, but it doesn't have a scroll bar method in it, say. And we want to say, we want to scroll to the top of the window. Then we can make that method accept as a parameter something which is a window and which also has a scroll bar method. And then we can say on that window, scroll to the top of that window. This is a bad example, but it essentially shows off the sort of thing you can do. The important point is that the nominal information and the structural information are closely tied together. The top type of Unity is constructed by the object class with no extra structural information. Right? The important thing there is that constructed by the object class is still part of that type. And what we want to do is make it so that the top type is just, there is no structural information here. We don't have an object an object class at the top of our hierarchy. So we don't have classes at all. How can we talk about class names if we don't have classes? So we've sort of split them out into two separate things. We have a window type and a structural type about scroll bars, and we join them together using the existing intersection operators. But we're essentially expressing the same thing. So one of the other important things about Grace is that the types are reified into objects at runtime. And instance of checks are just methods on types. So instead of doing an instance of special something that's built into the language, if you have that person type, you can call the match method on it, pass me in, and it'll say that I'm a person. And then we can do casting. There's a match case construct, and those type objects exist at runtime, and it essentially just does the same thing. The important thing being that they can still be reasoned about inside the body of the cases as types. So the dog variable has the type dog inside that branch. This is how we sort of explain it. This is how a lot of people explain it. This is how I think like Type Bracket also talks about. The talk this morning was talking about we take types and we turn them into runtime contracts. Those types turn into runtime contracts. And part of what I want to talk about is I think that that's kind of backwards. That in the case where these types are reified, really the types are just objects already. They're objects that happen to exist inside the language, and you've just chosen to reason about them statically. And in a lot of cases, limited where they can be used so that you can reason about them statically. Yeah, so if we're gradually typed, we occasionally choose to reason about them statically, depending on, I guess, what kind of gradual typing you have. So the system that we've built is looking at, well, if types are just objects, we have these built-in structural types, but really they're just objects that happen to behave like structural types, then why can't we construct our own set of objects that aren't built in? They're just some set of objects from a library we've made, and then treat them as types as well. And we have our Dialect system, which allows us to write sort of pluggable type systems. So if we have these our own objects and we can reason about them, then we can treat them as types. And the important thing is that we have built these brand objects without actually extending the underlying language. So this is how they work. There's no brand declaration as such. There is a method called brand, and in Grace you omit the parentheses if there are no arguments. So brand is a method, a side effect method that takes no arguments and returns a new object and constructs some new brand object. And so rather than writing brand a square, what we've done here is just constructed some new anonymous brand and then bound it to a name. So because we're not extending the language, we don't have a brand declaration as such. This essentially stands in for it, that we create one and bind it. And then we can brand an object. So in this case, we're saying this object is a square. And the is notation is just the existing annotation notation. So there are other things we can write there, the already existing annotations that we can put in an object, and the brands that are constructed from brands are also annotations. Yeah, you're going to need to mic.
Shall I wait for the microphone or just speak loud?
I can repeat the question.
Also, rather you should try to articulate your words and sentences clearly all the way to the end.
Okay. Okay.
It looks like brand is a single object that is used both for saying an object is of that brand and for testing.
Right, so we're going to come to that. So the question was, is the brand both a thing that you annotate objects with and the type that you test if an object is annotated with that brand? And no, it's coming later. It's important that they're distinct, and we'll see that in a second. That they are distinct. Yeah. Right. So we can also brand classes. We can say here is a class square, and you can. I don't know how well you can see the colors, but I'm sort of trying to distinguish between what the brands and the types are here. So the class is branded a square, and what that means is that the objects constructed by this class will be branded with the brand that you've written there, in this case a square. But it's worth noting that the return type of the class, which is separate, we have to put return types on classes because classes aren't real and they don't introduce types. So the type we've still got there is just the shape, the structural shape type. And here we go. The important point here is that the type and the brand are separate from each other. So there is a type with a capital T method on each brand, and what that does is give you out the first class nominal type, which essentially just checks if an object has been annotated with the brand. So now we can replace the shape type on the class with the square type, and everything will start working. And if we put square as a type, but we didn't annotate it as a square, we'd start running into errors because the things coming out wouldn't be squares. They wouldn't match the square type. And then the intersection operator is already around. It's part of the structural type system, and we can keep applying it here. So the brand type can be combined together with that structural shape type, and now we're sort of back to the full nominal types where we have both the structural type and the tag together as two separate things joined back together into one class type. I guess it's worth pointing out that this is just a design decision. It isn't necessary, but inheritance preserves subtyping. So if you inherit from a class which is branded, then the objects that come back are also branded in the same way. And we can also extend existing brands, so we can build the hierarchy of types that we want. So if we have a shape that's a brand, then we can declare a square and a circle not as new brands, but as extensions of a shape. And extend is just a method on that object again. And so an object branded a square is still a square, but it's also a shape. It essentially just translates back into the types and subtyping. And we can do multiple subtyping. We don't have multiple inheritance, but classes aren't involved in this process at all. So there's no reason we can't add brands together. So we can add a square and a circle together. We get a squared circle. And now we can annotate an object as a squared circle, and it satisfies both the square and the circle types because it essentially translates into annotating that object with those two separate parts. And that works in both directions as well, that the type of a squared circle matches exactly those things which have been branded by both its subparts. It's not in itself a unique brand, it's just the sum of those two parts. And then extend, the extend method is actually implemented in terms of plus. It's just self plus new brand, and that's how you get an extended brand. So if you did want this to be, if you wanted a squared circle to be unique, you would add a square, a circle, and some new brand together, and you get that result. So the separation is important because if you expose the type, you end up, and they're the same thing, then you've exposed the permission to brand other objects, and it's basically a waste of time at that point, because anyone who can see your type can also brand their own objects as your type, and so you actually end up having no guarantees anymore about what things are branded that way. So this was something I found after, which probably should have found before I started writing the paper, but it was something we found after writing the paper, where someone had already proposed a similar mechanism for some very distant future ECMAScript standard, and they had come to the same conclusion, that the thing that did the branding and the thing that did the matching, what they called branders and guards, had to be distinct. And it was fine to get from the brander to the guard, going in that direction was fine, but going back in the other direction was wrong, because it would break the capability model. Yeah?
Yeah, as a co-author of the text, I just want
Oh, great.
I just want to point out that the actual idea comes from the paper Protection in Programming Languages from 1973
right, there we go.
by James Morris, and was implemented in the Gedanken language.
Cool. I'm not going to repeat all that, but so it's cool that this existing work. It sort of turned out to be a bit obvious once we implemented it without this, and then realized straight away pretty much that it completely broke everything. We're as careful about using the word capability because its use is it's used quite a bit differently between different fields. So we've just kind of shied away from saying that. But yeah, originally this paper was a lot more about the capability model, and we sort of just backed away from that a little bit. So how do we make sure that no one gets access to the brand, but gets access to the type? Well, we just use the standard object-oriented features. We can declare a square as confidential, which is that you can essentially read as private, and then we make the type public. We just put them in two separate names, one with restricted access and one with public access. And then because our modules are just objects, there's nothing else we need. We just declare them at the top level. Now they're types in a module. Okay, so one of the questions we wanted to ask is our language extensibility powerful enough to introduce new type constructs, in this case specifically the nominal typing? And the answer is mostly yes, with some minor caveats. So we have our brand method that constructs new brand objects. We've implemented a accompanying static checker as a dialect. And all of those things are using the existing features of the language. We can do dialect checking already. We can do annotations already. The encapsulation is all just an object-oriented thing. And combining the types together is already part of our first-class type interface anyway. So yeah, this is particularly interesting because there's a lot of other people working on a similar sort of thing where we want to add types to these things and we don't want to fiddle with the underlying language. So the MyPy talk on Monday was particularly interesting in the sense is that they wanted to build a type system for Python, but they weren't going to fiddle with the actual runtime at all. So they had to fiddle with, they essentially built objects that represented the types and then chose to reason about them statically. That's particularly interesting because they chose to do nominal typing first and considering structural typing, but it hasn't been implemented. And part of why that's interesting is that one of the claims we make in the paper is that it will be harder to go, it's harder to go in that direction than in the other direction. So it's, in particular, what we're talking about here is that if we start with some structurally typed language, it's easier to add the nominal type stuff on than it is to start with a nominally typed system and add the structurally typed system on. And that's why the Unity stuff is a bit interesting in that all of the existing brands work is mostly focused on classes, and the nominal types are all focused on classes as well. And so all of the types you end up with are essentially nominal types equipped with some extra structural types. So part of why we make this claim is, well, you'd need a syntax for describing the structure of an object. There's a lot of infrastructure that you need for doing things like combining structural types together that probably aren't around if you've just got a nominally typed language. And also, you need to use reflection to look at the object in order to work out what its structure is. But it's more than that, because we could say, well, you know, the structural type stuff is just harder. So, you know, this isn't a very good claim, because what we're saying is if the hard stuff's already done, then it's easy to put the easy part back on top, right? And so part of what we're saying here is that for us, classes are the real problem here. That part of what the structural typing does for us is it allows us to say classes aren't real, there are no class names, and when we add these things back in, we don't have to worry about classes interacting with each other. It's so much easier because we just build these things that don't worry about classes. They're just representations of types. So a couple of things about our brand objects is that the names are still irrelevant. Technically, only the identity of the brand matters. It just happens to be the case that you tend to have to bind it to a name in order to use it. Yeah, so there's exactly one use case for an anonymous brand, and that's to create a type that's empty, because no one ever branded anything with it. And the extend method as well, but that you don't pull the type out of that thing. And yeah, so our static checker essentially tracks the identity of the brands as locally bound definitions. And it's worth pointing out as well that like the names are useful for things like error reporting, but that's true of structural typing as well. You know, you don't want to report back the full structural type of something, especially if it's a combination of series of structural types, anytime there's any sort of type error. Yeah, so a Dialect reason about brands that it can see, like it sees that a brand is bound to a name and it interprets that as a type. And so it looks at the brand method, looks at each request to the brand method, and it says that returns something of type brand. But the important thing is that it actually interprets the type as slightly different each time. So this is something that doesn't really make sense in terms of, if you wrote this, it definitely wouldn't make sense, but the point is that the identity of their brand is included in that type. So this isn't real, it's just a sort of a visualization of what's actually happening. And then that means that we can also put brand into the language as a regular type. We can do things like, we don't have to bind it to let, we can have a parameter so we can accept a brand as an argument to a method, and then use it as a static type inside that method. And that's where the tag types sort of one-up us, is that we don't have dependent types and we can't do cool things like this, where you say, give me a brand and I'll return something that's branded by that brand, which is unfortunate, but that's one of the things we need to look at in terms of language design. It's worth pointing out that our case studies are pretty similar to some of the motivating examples presented by the previous paper. We're looking at hierarchies of things where the structure of the objects in the hierarchies don't give you a good enough distinction between them. So things like the AST of the language, or the exception structure that was mentioned in the previous paper. We can't always tell those things apart just by structure, and we need some other way of knowing which one's which. We've also formalized the addition on a much smaller scale, and in particular, we haven't formalized any of the gradual typing. We assume that everything is already statically typed. It's extension to an existing formalization of the structural part of the language. And it works by essentially normalizing every requested brand down to some unique name. And that's essentially equivalent to what I was talking about before, where the identity of the brand is sort of statically found. And then there's this table, which isn't particularly empirical. It's a bit like counting lines of code and comparing, a bigger program is bigger because it has more code in it, but it sort of gives you sort of a vague idea of how much the extension impacted our system. So that the numbers on the left of the plus are what we've interpreted as the stuff non-related to the extension of branding to the language. Unity and the tagging language are both not extensions yet already, so we've sort of just picked out what we think contributes to the extension. And it looks like ours is a bit smaller. It's not exactly the most easiest way of telling whether or not our formalization is somehow simpler than someone else's. This is really the important point, is that adding the brands in means that it didn't really affect the proof that much. It was pretty easy to run the brand stuff through the proofs as well. The structural typing stuff had already solved all the hard problems, essentially. So the remaining questions for us are, what is a type? There's still a lot of disagreement in the designers of the language about what a type is, whether structural types are the only thing that can claim to be types, or whether types are anything that we choose to reason about statically. And there's also the let declaration that you've seen all the way through. It's not actually standard grace. It's the one thing we've really had to add in. It's not related to the branding, but we did need it in order to tell the dialects, we want you to talk about this as a type. And then do we go further and say, look, we can encode the fact that you can build a brand for every class and essentially recover class style nominal typing. But this is directly against some of the design goals of the language. I'm just pointing out that you could do it if you wanted to. So to conclude, really, like, from my perspective at least, when you want to reason about things statically, anything that you can, in a limited subset, can be types, essentially. And if we take that interpretation with the right language features, then we can essentially build libraries of new type constructs. We don't have to be stuck in one particular interpretation of types. And yeah, one of the claims that we make, where it's easier to start with a structurally typed language, what we're sort of saying here is that classes aren't really necessary for nominal typing, and in fact, moving them out of the way actually helps a lot with sorting out what's really going on with the nominal types. Great, yeah, and then if you want to learn more about grace, and you don't care about any of this, then Kim's giving a talk tomorrow at the summer school. There are some links to the paper and this talk, and we have an artifact as well that will be up at some point. So that's me. Thank you very much.
I was puzzled with your first motivation, because I couldn't see there anything that would differentiate, so make a difference between nominal and structural. But then I guess that you imply some additional connotations to the basic meanings of these words. Another thing, why did you choose a nonsensical example for multiple subtyping? So because an object can't be both a circle and a square. So you could have taken a square and a colored shape, for instance.
Partly because then you get into arguments about whether or not I should have just done that through the classes. I don't know, it was a funny joke, essentially, that a lot of people apparently didn't find funny. But you're right, there are definitely better motivating examples for that. Yeah, the point is that we can get that if we need it without necessarily having the class relationships there. You're right, though.
One of the advantages of nominal types and tagging is that if you know the class, the object has the tag, you immediately know the interface because the tag is formally connected to the interface. But as far as I could tell from your presentation, I should read the paper, it seems that the tag is not formally connected. The dialect may have a conventional connection between the tag and the interface, but there's no formal connection.
So we've implemented the branding on top of our existing structurally typed dialect. You don't have to do that if you don't want to. You could just implement the branding and ignore the structural typing entirely. I like the idea of them being completely separate. Like the tag types, when you declare a tag, you include the structural information inside of it. And part of it was to get away from the sort of hybrid type. You have both the class and the structural information all the time. But yeah, I mean, part of it is that we want to look at this library of types, and the smaller dependency that library has, the better. And so it doesn't necessarily have to depend on the structural type information if it doesn't want to. Certainly you could build it so that the brand method takes a structural type and includes it in the type itself. and then I guess insists that it has that type when it brands an object. Yeah.
So this is a question for both you and the speaker from the previous talk. It seems pretty clear that there's a relationship between the material of the two talks. What is it?
I've been trying to work that out, actually. That I was sort of thinking, well, for a long time we've been saying we've attacked the same problem and we've got a different solution, and then I was thinking, well, actually it's a different problem and we've come up with the same solution. And then I'm sort of convinced myself now that they're actually, they're related on a very broad spectrum of, we want to solve this problem of classes. Well, maybe I should just put a full stop there. Yeah, it seems like there seems to be a lot of interest now in being able to combine these two things. Theirs is, as I said, theirs is a lot more interested in the formal side of things. But I think what ties them together is actually quite broad, and what we have done is has a very different motivation and has a very different outcome than what they came up with.
Last question. I had a small question. What does the plus operation on tags do?
So you get a new brand, which is exactly those two brands that you. When you brand an object with the sum, it is exactly equivalent as having branded that object with the two things that it was a sum of. And in fact, the point I had there was that the type of the sum will still match things that are just tagged with the two separate ones. It's not even a new brand in and of itself. It's just a convenience, essentially, for joining them together and saying, when you brand it with this one thing, you're actually branding it with two or more.
So that's like the pipe operation on structural types?
So that the types correspond in the same way, but because the brands aren't types, we need a way to do that that's separated from the type language.
Okay, I think we'll have to cut it off.